This is 2023 AMC 10A problem 21. Let P of x be the unique polynomial of minimal degree of following properties. P of x has a leading coefficient of 1. 1 is a root of P of x minus 1. 2 is a root of P of x minus 2. 3 is a root of P of 3x. And 4 is a root of 4 times P of x. The roots of P of x are integers, with one exception. The root that is not an integer and can be written as m over n, where m and n are relatively prime integers. What is m plus n? So this problem is easy if you think about it in the right way. So firstly, let's just write P of x out. How can we write P of x out? Two ways to do so. One is you have the coefficients, for example, like this, so x to some power, and then a2, the second coefficient, x to some other power, etc., all the way to like the constant or something like that, right? So that's one way to write out the polynomial. Another way is just to do like a product, like factorization format. So it's just plain products, and each one is x minus one of its roots. So let's say its roots is x1, x2, x minus x3, etc. So in this problem, we're going to use this way because we've already got some roots over here that we can deduct. So firstly, and we know that P of x has a leading coefficient of 1. So we don't need any number here. Usually we need a leading coefficient over here, like k or something. But k is just 1, so we just leave that alone. Okay, so 1 is a root of P of x minus 1. What does this actually mean? This means, so when x is equal to 1, this thing is equal to 0. So being a root of something means that this is equal to 0, and there's a solution to so. So P of 1 equals 1, because P of 1 minus 1 equals 0. What about 2 is the root of P of x minus 2? This basically tells us when x is equal to 2, P of x minus 2 equals 0. So P of 2 minus 2, or P of 0, equals 0. What about 3 is the root of P of 3x? This is P of 3 times 3, which is P of 9, is equal to 0. And then we also know that 4 is the root of 4P of x. So this basically tells us that 4 times P of 4 equals 0. Or simply put, we know that, so simply put, if we divide both sides by 4, P of 4 equals 0. So we already have like 3 roots over here. So it looks better to write our polynomial in this way. At least we know some variables. So P of x equals, so the first root is 0. So when x is 0, this is 0. Meaning that, so there's a root for x equals 0. Right? So x minus 0 is just x. The second root is 9. So when x equals 9, this thing equals 0. So x minus 9. And then the third thing is 4. So this is x minus 4. And then there's probably some other roots we don't know about, like, yeah, etc. And then it says that, so it says that the roots of P of x are integers, so all of the integers, with one exception, the root that is not an integer and can be written as m over n. So it's like a fraction. Okay, so how do we figure out m over n? Well, we haven't used this clue yet. When you're stuck or when you don't know how to proceed, look at the clues you haven't used. Clearly we haven't used the fact that P of 1 equals 1. Well, how do we do so? We just like plug x equals 1 in. So let's just plug x equals 1 in and see if our equation equals 1 right now with these 3 terms. So this is 1 times 1 minus 9 times 1 minus 4. We'll ignore the other terms for now. So, and then, because, you know, above here, it says, let P of x be the unique polynomial with a minimal degree. Meaning we want as little terms as possible. Wait, how did I just move that? We want as little terms as possible. So if this is already equal to 1, then we're just like done with the problem. I don't know, we can answer like 2 or something. I don't know, like there's not going to be a fraction. So this is going to be 1 times negative 8 times negative 3, which is 24. So that's clearly not 1. So that's not what we want. So obviously there's a solution to this problem. There's an m over n that we must multiply 24 by. So what times 24 equals 1? So we need a fourth root. right? What times 24 equals 1? Well, 1 over, so what times 24 equals 1? Well, 1 over 24 times 24 equals 1. So anything times its reciprocal is 1. But notice that this whole thing here is 1 over 24. So this means that x choose 4, so x sub 4, the fourth root of x must be 23 over 24, such that when we have 1 minus 23 over 24, this is 1 over 24, and they will give us the answer of 1 for p of 1. So we know that x of 4 must be 23 over 24. Okay, so let's just rewrite our new polynomial then. This is basically telling us that p of x at minimal degree is going to be x times x minus 9 times x minus 4 times x minus 23 over 24. And there's no leading coefficient. The leading coefficient is just 1. So it looks like this thing satisfies all of our conditions, so it's actually just satisfying the problem. It's what we want to find. Now let's look at what we actually want to find in the problem, what we want to solve for. So the root that is not an integer can be written as m over n. We want m plus n. Now where's that root that's not an integer? Clearly 23 over 24 is not an integer. So m is, and 23 and 24 are relatively prime. So m is 23, n is 24. 23 plus 24 is 47. That's the answer. That's m plus n. So our answer is just 47. So we circle D.